Hello everyone, we are from the Vishay Regional Marketing Passives Asia team. I'm Yuan Gao.
I'm Wayne Liang.
Today we would like to share with you how Vishay's passive components can be used in the design of onboard chargers (OBC).
An OBC is a critical system in new energy vehicles. It converts AC power to the DC power required by the battery. It also determines the charging power and efficiency, which affects charging duration. With the technological advancements in electric vehicles, OBC designs need to meet the new market requirements. First, there is a growing need for functional integration. Many manufacturers are integrating OBCs, DC-DC converters, and PDUs in one box. Second, the power demand for OBCs is increasing to 22 kilowatts from 3.3 kilowatts. However, the size of the charger has to remain pretty much the same. This presents a new challenge for passive components like capacitors, inductors, and resistors. To improve the efficiency of the charger in the OBC's PFC and DC-DC circuits, the accuracy of both the current and voltage sensing play an important role. For voltage sensing, TMPW and TMPV series thin film resistors offer voltages to 1000 volts. Even in the harshest operating environments, these resistors have a maximum resistance drift of 0.05%, meaning voltage sensing will remain accurate throughout the vehicle's operating life. As for current sensing, WSL series resistors are made from a solid metal alloy and can handle power of up to 15 watts. They have a low temperature coefficient of resistance TCR of less than 20 ppm per degree Celsius and a low thermal electromotive force EMF of less than 3 microvolts per degree Celsius. We also provide a four-terminal design to enhance precision and ensure long-term reliability. If you require inductors for use in filtering and switching circuits, we suggest our IHLP series power inductors, which are fully enclosed and integrated, and boast exceptional magnetic shielding capabilities over high temperatures to 180 degrees Celsius without any impact on their saturation curve. For active and passive discharge circuitries, you can't use power thick film resistors, particularly DTO and D2TO series resistors. These resistors come in TO-263 packaging and can handle up to 35 watts. Compared with similar products on the market, DTO resistors can withstand 1000 cycles of temperature cycling. It is worth mentioning that gate driver resistors are used extensively in OBCs. Vishay MELF resistors are an excellent option due to their very high overload capabilities. MELF resistors can handle 17 times more energy than standard flagship resistors of the same size. In OBC design, the importance of temperature measurement cannot be ignored. Our NTC temperature sensors provide long-term stable performance in harsh conditions. Now, we will share about the capacitors in OBC application. Safety capacitors help filter common and differential mode interference in power supplies. Most importantly, they must pose no risk of electric shock or personal injury, even when malfunctioning. Therefore, they need to be highly reliable. Vishay manufactures highly reliable safety ceramic capacitors, including Y1 and Y2 devices. Our AY1 series capacitors comply with the AEC-Q automotive-grade application standards. These capacitors can handle pulse voltages of up to 10 kV, while our durable AY2 series can withstand 3000 temperature cycles from 55 degrees Celsius to 125 degrees Celsius. Both series can meet the strict requirements of automotive-grade applications, while successfully passing the challenging 1000-hour double 85 test. Moreover, these capacitors not only can withstand 1000 automotive-grade temperature cycles, can also withstand more than 3000 or even up to 4000 temperature cycles without any failure. Among the safety capacitors, Y capacitors require a small capacitance and a compact size, making ceramic capacitors a suitable choice, while X capacitors require a relatively high capacitance, which is why film capacitors are commonly used. Vishay's MKP339X2 series film capacitors can withstand high temperatures up to 125 degrees Celsius. Additionally, the F339X2 series capacitors can pass the demanding 1000-hour double 85 test, indicating they can withstand high humidity environments. As shown in the comparison test results, the capacitors exhibited a capacitance degradation of only 3%, which is much lower than the maximum acceptable limit of 10% required by the 1000-hour double 85 test standard. Apart from safety capacitors between the rectifier circuit and the DC-DC converter circuit in the OBC, DC-link capacitors are also required for current support filtering. They are designed to absorb high pulse currents from the DC-link bus and protect the load terminal from voltage spikes. Film capacitors, characterized by high voltage resistance, large capacity, and non-polarity, are well suited for DC-link filtering applications. Vishay's MKP1848 series is an excellent option for DC-link applications as it offers low ESR, high capacitance to 400 microfarads, and excellent ripple suppression capabilities. It can also handle a current of up to 54 amperes. In addition, Vishay's MKP1848H series features excellent humidity resistance and reliability, meeting the demanding 1000-hour THB test requirements at 85 degrees Celsius, 85% RH, and rated voltage. The MKP1848 SE series is the latest DC-link capacitor for height-constrained applications. With a height profile that can go as low as 12 mm, it is an ideal choice for customers who have height limitations in their designs. Finally, we will introduce the MKP385E series resonant film capacitors. They exhibit stable pulse intensity and ripple current characteristics. They can withstand high temperatures of up to 125 degrees Celsius and DC voltages of up to 2500 volts, while meeting the high THB test requirements per IEC standards. That's all for today, and certainly hope you find these sharing useful. Thank you for watching. Vishay's passive products are designed to simplify your OBC designs.